First of all, what is matter? Matter is anything that has mass and volume. Matter is made of atom. What is atom? In the center, we have a nucleus, which contains proton with a positive charge and neutron with a neutral charge, and orbiting around the nucleus with electron with a negative charge. Atoms bond together to create more complex things like simple molecule. A common example of a simple molecule that we use every day is sodium chloride or salt. Atoms can also bond and create even more complex molecule called extended structure. An example of extended structure is polypropylene, which is some type of chair is made of. Another thing about atoms is that they are arranged differently in different states of matter. In solid, atoms does, in fact, have motion. They don't move around, they vibrate in place. Solid has a fixed shape and fixed volume. Next is liquid. Their atoms spread around more and slide around. They have fixed volume but no definite shape. Last but not least is gas. Atoms move freely away from each other at an incredible speed. They does not have fixed volume nor fixed shape.
Next will be chemical interactions. How do you know if a chemical reaction had occurred? Well, there are 3 signs. First up is change in color. As you can see with this razor, the metal reacted with oxygen over time and became rusty, which caused its change of color. Second is the appearance of gas. Like you can see in the chemical reaction between vinegar, an acetic acid, and sodium bicarbonate, or also known as baking soda. When reacted to each other, gas bubbles up. Last will be the change in temperature. Before the reaction, the temperature of vinegar is roughly at 31 Celsius, and after the reaction with baking soda, the temperature dropped down to 27 Celsius. According to law of conservation of mass, in the chemical reaction, atoms are neither created nor destroyed. Take this chemical equation between vinegar and baking soda as an example. In the reactant, you have 1 sodium, 5 hydrogen, 3 carbon, and 5 oxygen atoms. For the product side, you also have the same amount of sodium, hydrogen, carbon, and oxygen atoms. Because atoms weren't created nor destroyed in this chemical reaction, therefore the mass also does not change. With chemical reaction, there's exothermic and endothermic. In baking, we have endothermic. The batter of brownies will absorb the thermal energy that the oven released to cook the brownies. Heat also helps the baking soda produce tiny bubbles of gas, which keeps the cake light and fluffy. It also changes the proteins in the egg, making the cake firm.
Following chemical reaction is motion and force. According to Newton's third law, if A acts a force on B, then B will give back the same amount of force but opposite direction. The gray car crashed into the black car, which caused the black car exert back a force that makes a gray car move backward, while the black car goes the other way. According to Newton's first law, if an object is standing still or moving constantly, then the net force of the object is balanced. Then, if we apply an outside force on the object, then the net force will be unbalanced, which causes the object to move or to stop. For the object that have more mass, you will need to apply more force in order the object to move.
Coming up next is light and sound. This is a model of a wave. The distance between each wave is called a wavelength. From the medium to the crest, the top of the wave, or to the trough, the bottom of the wave is called amplitude. The amplitude depends on the energy was used. For example, if you use more energy to talk, it will be louder. If you use less energy, then you will sound quieter. Waves aren't just about sound, they are also about light. It's the reason why we can see things. We could see the straw because the light wave hit it and then reflects into our eyes. But what about color? Here we can see the straw is purple. How? Well, light ray is being absorbed by the straw except the violet ray. The violet ray bounces back and into our eyes. How about black and white? Black is when all color are absorbed, and white is when all color are bounced off. For people with glasses, they can see through the glasses because light waves that bounces off from the object will transmit or move through the glasses and enter our eyes.
Last but not least, we will talk about magnetism and electricity. There are some factors that affect the strength of the magnetic force. First is how aligned the magnetic domain is. Second is the size of the magnetic, but this does not really affect much. Next is the distance apart from the magnet and the object. Last will be how strong is the pole. Usually, the magnet is strongest at the edge of it. An example of magnet in our daily life is our refrigerator. The strong pole helps the door not to open.
For electricity, the first factor that has the greatest impact is the difference of charges. Second is materials that conduct the electricity easily. Third is the voltage source. This have a great effect on the electricity. Last but not least is the distance of the wire. The example of the usage of electricity in our daily life is using things like laptops, cell phones, iPad, TV, the AC, etc. Have you ever wondered what does the circuit of the light you use every day looks like? This is what it looks like. The material that you need to build the circuit is a voltage source, a switch, a conductor or wire, and your light bulb. Then we connect all the parts together, in the right order and way of course, and there you have it, a light bulb that you use every day in your daily life.